Our next talk here is Daniel Mayer talking about iOS Blackbox testing or pen testing. So please give a warm welcome to Daniel Mayer.
Thanks. Good morning, everybody. So we had EDB right now, so now we're moving on to IDB, and a colleague of mine is going to talk about ADB later, so I guess we're going to cover all of those today. Any of you guys are involved in iOS mobile development or pen testing or things like that? Okay, a few people. So before I get started, just quickly about myself. I'm a senior consultant with Matasano Security. We're an application security consultancy. I'm based out of Chicago, but we also have offices out in Chicago, New York, and Sunnyvale. And we're part of the NCC group, which is also ISAC partners, Intrepidus. You may have heard of some of the companies before. So mobile, why is mobile important? As you maybe have seen similar graphics in the past, so since 2014, we have basically surpassed the desktop users in the mobile space. So there's more mobile users than we ever had, than we currently have in the desktop space. And then if you look what mobile users do with their phones, well, most of them are actually using apps. It's not like the mobile web. It's really people using applications. So application security becomes a pretty big deal because all that sensitive data is stored on the device and people carry it around with themselves. So anybody here had like their phone lost or stolen ever, or know somebody who did? You don't want to say it yourself? Well, apparently you're all too old because young people seem to lose their phones very, very often. If they, the statistics, if you're between 18 and 24, like 45% of people apparently have had their phone lost or stolen. And then people get better at keeping care of their things, I guess, or they just don't use phones so much. Yeah, so with this in mind and knowing that we use phones so much for storing things on them, data protection on the device and for applications becomes really a big deal. And that's why mobile security is such a big field at the moment. So I'll first give a brief introduction about applications on iOS and then talk about a reasonably new tool. It's out there for like half a year now, but there have been some improvements over time, so hopefully not everybody has seen it yet. And then I'm going to walk over a bunch of common iOS vulnerabilities, and I will talk about what they are, how you can use my tool to test for them, and also how you prevent them or mitigate them in your own code or own projects. So iOS has actually really good platform security, especially compared to other devices like Android. It's really much more tightly controlled. If you look at Windows Phone, I think they're also doing a really great job. But what's special about iOS is that all apps are sandboxed. And they're not sandboxed like they are on Android, where you have different users for each of the different applications, but they're all running at the same user, mobile. And they're having like a kernel level filter, which checks all system calls and makes sure that the application is allowed to access the data which it's trying to access. And in addition to that, we have application signing. So all code which is being executed by the kernel is actually checked if it is signed at runtime. So it's not like a check at install time only, but actually when the code runs, it's checked if there's a proper signature on it. And that's basically what you're bypassing when you jailbreak your phone. That's like one of the things which is being bypassed, that you can get your own code on the phone, you get root on the phone, and you can run everything you want. From a platform standpoint, we have all the modern protections which we have on desktop operating systems, data execution prevention, and address space layout randomization, which just make it much harder to write any exploits for those platforms and exploiting any flaws which are out there. The last jailbreak actually went really quickly, but compared to iOS 7, where it took a really long time to find a jailbreak, that's because all of these things are working pretty well unless somebody finds a bug and then is able to get the exploit going. And a really big part of the platform security is the passcode, and now the Touch ID. And that ties in a lot of the encryption data protection features, and I will talk about those along the way. So iOS applications, most of them these days are just native apps. They're written in Objective-C and C++, which is kind of a superset of C and C++. You can still use C and C++ instructions as if you want to. And the UI is the Cocoa Touch GUI, which is basically what's on the Mac, just customized for the mobile space. And there was a long time when we had like these web view applications. It's like, oh, we have to have an app. So we make an app, but we only have one big web view, and that web view just shows their mobile website. So those things are still out there, but there's not so much logic for on the device. It's more like only the web view, so you could get like cross-site scripting or something like this, but nothing more. So the focus will probably be more on the native applications. So if you think about an application on a mobile device, like everywhere, usually we have attack surfaces wherever there's like a trust boundary. So everywhere where somebody is interacting with your application. In this case here, this is your app, symbolized by this thing in the middle. And these are all the things around it which it talks to and which it interacts with. We have users just typing into it or interacting with the application directly. We have network communication with some sort of backend system, some sort of API, something like that. We have integration with the operating system, and there's a lot of things which can go wrong there. How is data being stored on the device? Is there things being logged? Are there other information disclosures? And then also interaction with other applications. So if you look at single sign-on applications or things like that, where on the device there's communication between apps, that would fall into this. And then, of course, you can just get the device stolen. And then you have a whole lot of other things to worry about, which are not remote attacks or attacks based on these factors. And we're going to talk about each one of those a bit in detail. So if you're going into pen testing, so I'm a pen tester, if you want to do pen testing or assess your own applications, what you usually do, you need a jailbroken device. Without a jailbroken device, you don't really have many insights into what's going on with any of the applications. You can't modify anything. So you want to jailbreak it, and then you get SSH access with the full Unix environment on there. You can SSH in there. You can look around at all the files. You have root privileges. You can do whatever you would like. And there's also something which Sorek wrote, which is Jay Friedman. It's called Mobile Substrate. It used to be Cydia Substrate before. And what it allows you to do is it hooks system functions. You can hook any system function and can redefine it at runtime. You can do that on the fly with like a JavaScript-like interface, or you can compile tweaks which are compiled into which are actually executed at boot uptime, and they're always there. And that allows you to bypass all kind of protections in either an app or in the operating system. So that you can bypass SSL certificate validations with that, or password screens on the device, and so on. So I will talk about some more of that. And then if you look at the network communication, you also need like some sort of intercepting proxy or something to monitor what's going on the network. So that's kind of the two sides, the device and then network communications. One neat trick which I just put in here that if people are not so familiar with, there's something called USB-MUX-D, which allows you to SSH via USB. So you just connect your iPad via USB to your laptop, and then it proxies TCP connections over USB, and you can actually SSH into your iPad via the USB port. So you don't have to have a Wi-Fi network or something where you get both of your devices on. It's kind of useful to know, just as a reference. All right, let's talk about the tool. Well, there's many great tools out there before I started writing this, but it turns out they're really, really scattered. So there's like one tool which does this small little piece of useful things. And then there's another one, and they all require different things. Sometimes you need a developer account to compile the tools yourself, and it's getting just really tedious to get like a big picture of an application. So the idea here was to fully understand an app with as many different angles from different angles as possible, and make it so that it's somewhat easy to do. So I'm coming from a dynamic testing background, so this is not like a disassembler or something which works on the static analysis level. It's more, how does an app behave? Where does it store data? What does it do with it? And the goal was to have like a tool which allows you to look at all of these different aspects and then get an idea of what it does. It's not like click a button and it tells you this app is secure, or you get a check mark for each of those things. So what is IDB? It's basically a Ruby app which has a Qt front end. It's a little bit of an outdated screenshot, but that's kind of how it looks like. And it integrates a bunch of the existing tools which were out there, and I also added a few new features which haven't been out there before. And it also makes it really easy to get started with this. It makes it much easier to set everything up and get access to the device. So let me just start off with the first demo. I think I'm going to switch this to mirror so I can actually see something. All right. You can see this, I guess? Yeah. OK, so this is how IDB looks when you start it up. The first thing you want to do is you go to the preferences. And here you can see how you would like to connect to your device. You can choose that you want to do it via USB, which I just talked about earlier, or you can SSH into it directly. If you already have your device on a Wi-Fi network, you can just SSH in. So if you're now on the Wi-Fi and you know my credentials, please don't reboot my device or do anything with it because it's on the Toorcon network. So you just put your credentials in here. And then something else which is really useful is you can do port forwarding. For example, I can say I want to port forward the remote port 8080 to my local host 8080 here. So if you want to intercept any traffic for proxying, you can then set a system proxy on the device to localhost 8080, and it's going to be magically proxied to your desktop computer. Or if you have other apps which are doing things on different ports, you can just forward those in both directions. It's just the regular SSH syntax for port forwarding. And then there's one option here for defining a SQLite editor, whatever you want to use to look at SQLite databases. So when you have this done, you can go into the device menu and click on USB device. It's going to connect to the device and says, oh, let me make sure that we have all the tools installed. And it popped up this bigger dialog here. I can also use the zoom. So basically, it checks that all the tools which it needs are installed. And if they're not, there would be an install button here. You just click it, and it would either copy the file over from my desktop, or it would install it via apt-get on the device. And when everything is on there, you're basically ready to go. So now the connection is there, and you can see down here some basic information on which kernel it's running and what's going on there. And you can also just pop up a terminal, make it a bit larger. And now I can just do SSH localhost port 202020. At least I think it is. Well, hey, the first demo fail. Actually, it's not the first. I forgot the iPad back in Chicago, and I had to get it overnighted here. So it came this morning at 8 o'clock. So I guess that was the first demo fail. Cannot really get much worse. Let me see. Oh, I think I know why. Yeah, I'm already SSH'd in. That would do it. So now it works. Yeah. Alpine 2. There we go. All right, so now we're on the iPad. So you can just SSH to the local host, and you don't have to worry about connecting it differently. So now you can just browse around, whatever you want to do on the device. You can look at the file system, whatever you would like. But this is just something which just makes it easier to get there. So the other thing is the intercepting of the traffic. If this should get this display over. There we go. That should be my iPad right here on my desk. So if I go in the settings of my iPad right now, and I'm going to the Toorcon network, and I'm setting the system proxy to this localhost 8080, as we just said. And then I'm gonna pull up burp here. I guess you're familiar with burp, right? It's just an intercepting proxy to look at HTTP communication. And then I'm just opening here my browser and a tab on Google, and then I see my interception is happening on my desktop. And I can look at the traffic, I can forward it and modify it, whatever I would like to do with it. So that just makes it much easier to get this thing going, just by clicking connect in the app. Right. So that's kind of the thing how to get started. We're going to talk about all the other functions as I go through the presentation. One thing to see here is if you want to analyze an application, the first thing you do is, well, actually, maybe I should just show this later. That's maybe better. Let me do that. So turning that back off. All right. It's going to sit down here. So what are common application vulnerabilities we're worried about on mobile applications? They're somewhat different than so there's some similarities to web applications, and there's some similarities to desktop applications in a way. And OWASP has something which is similar to the web application top 10, the OS top 10 for mobile, which has just been updated for 2014. It's a project which is maintained by Jason Hedix. And we have different categories here, starting off with like server-side controls, but then we also go insecure local data storage, insufficient transport layer security, which affects backend systems and things like that. Data leakage, some information leakages on the device. No authentication or authorization controls. This is kind of a combination between a local and a remote vulnerability category. Broken crypto is something which is very, very often the case, and people try to protect data with it on the device, and it most of the time fails, so there's a big problem there. Client-side injection, I don't know, it doesn't really happen all that often, but they have it on here. And then security decision on untrusted input, improper session handling, lack of binary protections. I think they're pretty clear. And if you look at these, most of them are really client-side issues. Except for like improper session handling and the server-side controls, everything else affects really the client side for mobile apps. So let's tackle those and go and see what the problem is. Let's start with the binary itself. So it's Objective-C and C++ code. So it's compiled code, native code, and you have all your goodies, which we just kind of talked about a bit in the previous talk. We can have buffer overflows, we can have format string flaws, use after freeze, all those things which we had back in the days, they're still working. We have ASLR, so I guess it's helping to prevent a lot of those things to being exploited, but you can have those things. By the way, if you're interested in learning a bit more about exploiting these kind of native code things, my company is running the CTF on microcorruption.com, which is running on an embedded chip, like a 16-bit microcontroller. So it's a good platform to practice because you're kind of traveling back in time to when there was no protections on the devices, and you can learn it step by step how things work. So the other thing about binaries is that very often they're used as a storage space. The developers oftentimes think like, well, it's a binary, nobody sees what's in there, so I stick my credentials in there. So API keys, sometimes AWS credentials, secret keys for AWS, everything just in the binary hidden in there. So that's obviously not a great idea. So what would you do in order to protect yourself as much as possible? Well, the first thing is if you want to actually have ASLR protections on iOS, you need to compile your binary as a position-independent executable. And there's two options for that in an Xcode, which you have to set. If you don't do that, then you're just having everything non-randomized, and you're having a regular binary. There's also something called stack canaries. Probably familiar with those. They're just magic values which are put on the stack in front of sensitive data, and if they're being overwritten, then the application of the program will terminate. So it's a very basic buffer overflow detection. And automatic reference counting is something which has been introduced in iOS 4, I believe. And it basically keeps track of all the pointers which you have to objects. So you minimize use after freeze or double freeze and things like that. So it's just making it a bit more a bit easier to prevent those kind of flaws. And obviously, we don't want to store any kind of credentials in the binary. Right, let's get me to the demo for that section. Right, so if we want to look at an application, the first thing you do is you just click on Select App. This loads all the applications which are on the device, which I installed on there. So I installed some apps from the App Store. We can maybe later, if there's time left, we can just install some apps from the App Store and just look at them. But what I'm going to use for the demo right now is going to be Divya, which is the damn vulnerable iOS application, which is it's kind of like WebGoat or things like that. It's a training application which I forgot the name of the person who wrote it, but it's a really nice thing. They have solutions and walkthroughs, and so if you're interested in getting more into the development side and how to make it securely, that's a good app to look at. So if you click on this, let me zoom out a bit more. So the first thing it does, it just pulls it in, and it shows you some basic information about the app. So it shows you the bundle ID, and it shows you the name. It shows you if there are any URL handlers registered, platform version it is compiled for, things like that. And then down here we have the button to analyze this binary. It's going to do some basic things. It pulls it down from the device. It checks if it's encrypted. In this case, I installed this myself, so it's not encrypted. It checks if it's compiled as a position-independent binary, has stack canaries, automatic reference counting. It just gives you flags for that. So if you want to make a quick check if that's in your application, you just get it basically for free. Well, there's also a button to launch the app, which is not all that exciting, but I'm going to show it to you anyways. If you click on launch, it's just going to launch the app on the device. And then over here, we have like basic functions to look at the binary itself. So the first thing it does is the shared library listing. So you just click on refresh here, and it dumps all the libraries which are imported by the app. And for all the system library, that may not be that interesting. But if you think about the OpenSSL flaws we had recently in like outdated OpenSSL libraries, which were vulnerable to all kind of interceptions, well, this may be a really quick way to just look at which version of OpenSSL is this linked against and which one is being shipped with it. So it just well, spits it out for you right away. And then we talked about storing things in the binary. Well, this is just running strings on the binary, which may actually sometimes give you really useful insights already. Some of this is just like artifacts from compiled code, but for other apps, you see interesting things in there. Actually, let me pull up the PayPal app just to illustrate this. That is, I believe, on the byte level. So I think if you have Unicode in there, it may be hex, and it will not show up here. But I'm not 100% sure. It's actually not running my own string utility. It's running the system string utility. So if your string utility can do UTF-8 or something, then it should work. So now I pulled this the PayPal application. That's from the App Store. And down here, you see that this one is encrypted. There's a true down here for encrypted. And if I now run strings again on this, you actually see more interesting things like card type and all kind of data about whatever the internal application may be using. And then there's also this crap which you always have in binaries. So sometimes there's some easy fixes in there. For example, if the app is using certificate pinning, which I'm going to talk more about later, but you may find the certificate in here. You may find API credentials in here. You may find URLs which you can use for fuzzing or API endpoints. It's just good to get quickly something out of the application. And then we also have the weak class dump integration, which allows you to the object model in Objective-C allows you to basically walk the entire available classes inside the application programmatically. It's kind of like reflection in other languages. But what this function does, basically it runs the application and it extracts all the classes which are in there and all the functions and all the parameters. So I rerun this because PayPal is really big. But you get all the classes which PayPal uses listed here. And then you can just click on them and you see exactly which kind of function it has. If one has set extension HTML, extension URL. And for example, if there's anything in an app, for example, one thing I've seen is like, Words with Friends, this game where you can play kind of like Scrabble over the internet with people. And they were doing the check if a word is valid on the client side. So people could cheat by overwriting their is this word valid function and just hook that and always return true, and they could play any word and they would always win against their friends. So this is like obviously a stupid example, but I mean you can do things like that by just hooking the app and override functions which are checked in the application client side. And in order to hook it and override it, you need to know what's there first. So this one gives you the header files for all classes and all functions in there, and it helps you to get a good understanding on how the app is structured and what's happening inside the application. I didn't write this, so the class dump thing is something which Elias Laminas wrote, and it just integrated it. So that's a software which is free to use, and I just integrated it in here. OK, so I think that's the part about the binary itself. Let's go back to the presentation. And feel free to ask questions at any time, interrupt me. Yes, I know there's an update. OK, let's talk about the elephant in the room, so to speak, for local storage on mobile devices. Well, so first of all the apps are sandboxed on the device. So they all have their subfolder, and they all have the same structure. So you have your app, and you have the app bundle. That's similar to OS 10, if you're familiar with that. Basically, all the application, all the supporting files, they're all in there. And then the application can have a documents folder and a library folder. And ideally, documents is like if you have let's say you have an MP3 player or like a podcast player, they could put in the documents folder all the MP3s you download. But it should not really contain anything which is sensitive or application specific. And all these apps are stored on the file system in private var mobile applications. And then there is a GUID, and in there is just this folder structure. And if the device is not jailbroken, the app can only access things in their own sandbox. You cannot move from one sandbox into another. But when you jailbreak the device, you can bypass that protection, and you can just get to anything anyways. Something which is really interesting is that Apple used to allow you to read these things from iTunes for backup purposes and things like that. There's a tool called iExplorer, which allowed anybody, it's just a GUI browser. You just connect your device, you install the app, and you can browse all the application sandboxes. Until iOS 6, I believe, you could also look into the My App, into the application bundle. So without jailbreaking, you could just go onto your device and see all the configuration files and anything which is on there and could download them. Now this folder is read-only and read protected for anybody but the device itself. But you can still browse any documents, library, and temp folders. So if an app stores things in there, even just a regular user without jailbreaking the device can just pull any files off the device. So not a good place to store things. It's also important to note that all these things are stored in backups. So if you backup your device to your desktop, you're suddenly moving all the data which the apps have on the device onto your desktop. So if you have a compromise there, any kind of malware, anything, CryptoLocker or whatever you can think of, that can compromise your data in a backup. And obviously, if your device gets stolen, somebody can just jailbreak it. And oftentimes, the jailbreak doesn't delete all the data on the device first. And then you can just have full file system access and you get to the data. And that's mostly the main point what people are concerned about, especially corporations. If you have basically all your intellectual property on the device and carrying it around all the time, people forget them in taxi cabs and whatsoever. So you have to really protect data at rest. And that's like a main challenge. So let's look what iOS does for that. First of all files are always encrypted on iOS. But the problem is it doesn't really help you much because the encryption is completely transparent. So if you encrypt it and you call the read system call for that file, the kernel will just transparently decrypt it for you by default. So there is no protection there, but the data is encrypted. And they have a encryption key per file. And that allows you to have very fine-grained protection classes for the file. So let me run you through this diagram here on the right. All iOS devices have a device UID, which is unique to the device, and which is not even known to Apple. That's what they claim, even in their own security document. So let's just trust them on that. And that one is stored in hardware. So in the manufacturing process of the chip, it's going to be baked in there, and it cannot be read out of there. But there is functions which allow you to use that to generate a key and to encrypt data with it. So encryption for a device is specific to the device. So if you get a file off the device, you have no way of getting the key and decrypting it somewhere else, basically. So if you want to decrypt the file, you need to run the decryption function on the device. And why this is particularly relevant if you think about a passcode. If you combine this with a passcode, I'm going to show you over here. If you have the device UID and the passcode together and data is encrypted under both, then you will not be able to brute force the passcode somewhere offline. You have to do the brute forcing on the device because you don't have access to that device UID, which you need for decryption. So the way they implement this is that you have the device UID, which in combination with the passcode, if you have one, gives you encryption keys for the file system and a specific protection class key. And the protection class keys give you different layers of protection. I'm going to talk about those on the next slide. But then those two together are being used to encrypt file metadata, which includes the file key, and the file key encrypts the data. So depending on the protection class key, you may have the file key protected under the passcode, or you may not. So if you don't have the passcode set, like in this situation, then you only have a key which is based on the device, and you don't really have any protection. As long as you have physical access to the device, you can always decrypt the data, because that's this transparent thing I was talking about before. But if you have the passcode, the way it works is that they derive a key from the passcode using ppkdf2, which is a key derivation function. And then they're using that derived key to encrypt the file keys. So without the passcode, you don't have the encryption key for files on the device. And the interesting part is that they delete the passcode from the device and the corresponding derived key as soon as you lock your device. So when you lock the device, that key is wiped. So it's not on the device anymore. And even if somebody gets access to it, they will not be able to decrypt it, because they would only on demand, when you type in your PIN, they would rederive that key and use it to decryption. So that's kind of how the protection works for the PIN. But if you don't have a PIN, then basically nothing is really secure on the device. So that's kind of the bottom line here. So we have to have a PIN. So people don't like PINs. So what did Apple do? Well, they introduced the Touch ID thing. And the way Touch ID works in this case is instead of doing the instead of doing the I lock my device, I wipe this key procedure, in the case of a passcode is if you lock the device, they re-encrypt that key under another key, which is derived from your fingerprint. So when you lock the device, you put your finger on the device, they derive a key, they use that key to decrypt this guy, and then they can get all your data. So there's like a trade-off there that the key is derived only from your fingerprint, which may not be that secure as a long passphrase, but the usability is much better. So there is a trade-off between security and usability. Yeah.
If you have a longer pin, is that used as a better seed as opposed to a 6-digit pin versus a 4-digit pin, or is it all the same when it generates the key?
Well, as far as I understand it, the pin is used to derive this key, and the more entropy you have to start with, usually the better is the outcome. So that key maybe have more entropy in it if you have a longer passphrase. But these key derivation functions are really good in getting pretty random looking things, random enough things out of there. So from like that standpoint, I wouldn't be too concerned if you just have a 4-digit pin to get something out of it. And from a brute force standpoint, that's a different story. People have built mechanical machines to type in pin codes on the device to break things. So with a 4-digit pin, there's only like 10,000 attempts, but you're getting locked out. And there is a hardware counter actually for the lockout, and then you need to connect it to iTunes and reset the whole device. And the same thing is true for the Touch ID. If you touched, I think, 5 or 10 times wrong, it will, again, wipe the key entirely. It will not even try to keep it. And you have to re-enter your original passphrase, and then they can rederive that key and use it. So it seems like it's a reasonably well-designed system for that. Yeah?
No, how that key is derived from the fingerprint?
I don't believe so.
Also, is there a way to pull that fingerprint-derived key off the device?
No. Yeah. Yeah. So that's the secure enclave, and so they derive from your fingerprint. They derive. So they claim they don't have the minutia data, which is the data which actually allows you to reconstruct the fingerprint itself. They derive some vectorized graphics from that, and then they use those to derive the key, and that's happening in the secure enclave. So they're storing it in some encrypted shared memory they have between the two worlds, the secure world and the other world, and use that. Okay, so this is a bit complicated, and especially I don't know if I explained it very well, but and I think any questions on how this works? Yeah, back there.
Were there any changes made from iOS 7.8 on the level? Like, am I saying pin cracking work for the new iOS 8?
For the pin? Sorry, the cracking for?
Was there any encryption or key derivation that was changed from iOS 6 or 7 to 8 that would prevent me from doing some of these tools like pin cracking or?
Yeah, so I think the main problem with that is that the iOS 8 jailbreak is just 2 days old. And everything we know at the moment about how iOS 8 is doing things is from the official Apple iOS 8 document. And then don't have so many details on exactly how they do low-level things. They kind of explain it on a higher level, but they don't exactly tell you which functions they're using. So you probably need to wait a bit longer to figure out if there has been any major changes. Once you get access to a jailbroken device, it should be much easier to figure all that out. But the jailbreak is out since like 2 days, so hopefully we're going to have jailbroken iOS 8 devices for pen testing or research. All right, so now I talked all about these protection classes, and they're using, so iOS has, well, yeah, I think this is still valid. For the keychain, something changed, but I think for the file protection, it's still only these ones. So you have NS File Protection Complete, which is the one which actually protects the data when the device is locked. So that is the one which uses the key on the right side, which I showed to you, which is protected by the pin code. If then there is complete unless open, which protects data when it is stored on the device unless somebody opens, unless it's already open when you lock the device. So basically, they keep the file handle available to read the data, but if the file is closed, you cannot get to it. Then there is something which is pretty funny, is complete until first user authentication. So if you always carry your device with you turned off, like what we always do with our mobile devices, right? Then it's secure, because the first time you log into your phone, when you turn it on, everything is unlocked forever after. So this is, I mean, if you go through, I don't know, airport security and you're concerned somebody's confiscating your device, that will help you in that situation, because if you have your device off going through security, somebody cannot get to it. But in all other cases, this is not really particularly useful. And then the default is none. So by default, there is no protection. It's encrypted, as I said before, but there is no protection whatsoever. Anybody can just read it. So obviously, you want to go for complete. The only disadvantage with complete is that if you have background processes going on, where you have the device locked and you want to make queries to some API or something like that, and you need to have an API key which is stored somewhere securely, you cannot do that, because the data will not be accessible to you unless you keep it in memory. So that's an option. So if you look at the data, like the NS file manager, this is like Objective-C code. I don't know if anybody loves Objective-C. I don't know anybody who likes Objective-C. So down here is the relevant part. So you have the file manager, and you want to create a file, and you have some contents which are going in there, and then there is an attributes dictionary. And all you do is you pass the NS file protection complete for the key NS file protection key. And when that file is being written, it from then on is encrypted based on the pin code forever. If you modify it or anything else, it's going to stay encrypted. So you don't have to worry about it anymore. Once you set the attribute for that, it's going to automatically be encrypted. So that's what you might want to do for any data stored on the device. So a little bit of warning here. The iOS crypto frameworks are really hard to work with, let's put it that way. It's not, and it's really, really difficult to write your own crypto and to get it right. So if we're doing a lot of crypto reviews in our work, and we have a crypto practice which does pen tests for these kind of things. And it's really difficult to get these things right. So the main problem on the device is what I talked a bit lengthier about the passcode. Where do you get the key from? If you store the key on the device, well, then you're relying on operating system protections to protect that key, because otherwise somebody who steals the device can just get to it. So in that case, why don't you just use the operating system protections in the first place? Because you have to write to them to protect your key anyways. So my recommendation would be to always use the iOS provided protections if possible, except for one reason. If you cannot enforce that the user has a passcode on the device, or that you know that your users won't care about it, then you have a problem. Because if they don't have a passcode on it, then any data, even if you set it to complete, will not really do anything. So you will not have a protection there. So what you would need to do in that case is to have like a password screen in your app, and derive a key yourself from that pin, and then encrypt data with that. And to get that right is kind of tricky. So I would recommend looking into like existing libraries like libsodium, which is based on the SALT library, NaCl. It just kind of wraps all complicated crypto in like a nice wrapper and makes it easy to use, and kind of avoids most of the pitfalls which are usually out there. So that's like a good way of doing it. And if you're interested in crypto, another shameless plug here, email cryptopals@matasano.com, and we have some crypto challenges going on. Has anybody done our crypto challenges? You don't count. OK, so if you guys want to, it starts you out with like really hands-on crypto. It's not mathy. It's just like really how to play crypto in the wild. So it's fun to do. All right, so let's talk about how is data stored on iOS. The first thing is SQLite databases. You're probably all familiar. It's just a way of persistently storing relational data on the device. And by default, if you use SQLite storage, it's an unencrypted file on the file system. So if you, I used like this app for playing with this, which is just keeping your loyalty cards or something like that. And I just used the SQLite editor to open it up, and you just find your loyalty card numbers and everything there in plain text. So these numbers are just in plain text by default. So obviously, you want to either store that encrypted using the data protection complete, which I mentioned before, or you can also look into existing third-party solutions. I'm not endorsing this because I actually haven't looked at it very deeply, but there is on a database level encryption for SQLite databases called SQL Cipher, and that one may be a better choice if you have larger data and you don't want to load the whole data in the memory. There's all kind of restrictions when you do it otherwise, but SQL Cipher may be something to look at. And also, if you delete data on a SQLite database, it's not gone. It has a journal, and it keeps it on the device until a certain, I guess a threshold is reached. So you might always want to make sure that you always truncate the database if you delete sensitive data from the device. The other big part, which is used a lot, I think on OS X as much as it is on iOS, which are plist files. So that is property list files, which are for structured data. And the idea here is that you can store dictionaries or just like key value pairs, things like that. And the way most developers use this is either NS user defaults, which is how Apple promotes this. It's very easy to use. You just put your structure in there, which you already have, and it stores it nicely either in an XML file or in a binary representation of that XML file. And very often this is used for crypto keys or for authentication tokens. This here is the path application I just looked at randomly, and they just have the OAuth token, which is just right in here. So you can just get the OAuth token for that user. So if you get access to the device, you get the token, and then you can just make any API request as that user. So obviously, don't store anything sensitive in there. This is from one of those demo applications here. So if you have like large amounts of data, you can store that in like a file and use NS file protection, which I talked about. Or we can use the keychain to store data, and I'm going to talk about that now. So the keychain is just a key value store. You can basically store the same types in there as you can store in a plist file. And it's internally stored in a SQLite database, which is on the file system located here. And the way this works is that the whole database is not encrypted, but actually per key, per row in that database, particular encryption is applied. And that allows you to have, again, this fine-grained control, which we have seen for the files. There's equivalent controls for data in the keychain. The first one is data is accessible when unlocked, accessible after first unlock, always accessible. And then there's a new thing. And that's actually kind of interesting, which they introduced in iOS 8, which is accessible when passcode is set. That's exactly for the scenario I was talking about earlier, when you cannot know if a user has a passcode set. Because if you store something in the keychain, you're kind of assuming that it's safe there. But if the user doesn't have a passcode set, you cannot really think it's safe, because the user, somebody getting access to the device still has access to the keychain. So they set this feature, and I believe the way they meant this to be used is you try to write something to the keychain, and if it doesn't end up there, you kind of have an indication that there's no passcode on the device. And then you can either warn the user and tell them, hey, we cannot store this here. You have to log in every time. We cannot store your credentials on the device. You might want to set a passcode first. But otherwise, these work exactly the same way as the file protection ones I've talked before. One interesting variation here is that there is also a flag called this device only. So these ones would be called ksec error accessible always this device only, which prevents data to be migrated to a new device. So if you have something which is specific to like a user account or a device, if you have a unique device identifier and you don't want it to be migrated by a user to a new device when they buy it, you can set that flag and it will not get into backups, and you cannot restore it to a different device. So you keep that out of backups. All right, the last part here is the keychain has a nice way of sharing data between multiple of your applications. And the way this works is that every application has a unique identifier. I'm going to call it an app ID here. And that's composed of a bundle seed and a bundle ID. And the bundle seed is something which Apple generates for you. In this case, it just shows something. It's a hex value. And then there is the bundle ID, which you choose yourself. And the bundle ID has to be unique for your organization. But this one is generated by Apple, and they guarantee you that it will not collide with anybody else's bundle seed. It's just a randomly generated token. And what you can do is, when you store data in the keychain, you can mark it so that it is accessible by everybody which has the same bundle seed. That's called a keychain access group. So you can store data, and you can say everybody which has the keychain access group beef1337 here, everybody who has that can get access to that data. So if you have multiple applications from your same institution and you want to share credentials, you can store it in the keychain, and all your apps can get access to that in a secure way. Right. Next demo. All right, local storage. So let's look at the storage tab over here. So I'm not sure if this app has any plist files. We'll see. So you click the refresh button. And apparently PayPal is a bit larger. So, oh, OK, there's plist files. So you get all the plist files listed. Can you read this, or is it too small? Is this better? So you get a list of all the plist files, and you also see the data protection behind them. So these ones are all not protected. It's not necessarily bad. I mean, this one seems to be like a language list, so that's probably fine. But if you want to have, if you have more sensitive data, you want to make sure that it's protection class complete here. What you can do now is you can just double click on this, and IDB will just pull it up in your editor, and you can just look at the plist file. So this is just a list of countries, but there may be more interesting ones somewhere. Let me see if there's any. Yeah, so basically double click on it, you can pull it up, you can inspect it, really easy. You don't have to download the file manually, it does it all transparently for you. Same thing for SQLite databases. This one doesn't have one. Let me move to an app which has. I think I have to click here. Oh, sorry, it is. I think Twitter has one. Yes. So here you see they marked this one as complete until first authentication. And again, you can just double click it, and it's going to open your SQLite editor. And then you can browse the data which is stored in there. I haven't really used this app yet, but there is all the data in here. You can look at it, and you can see if there's anything interesting. And CacheDBs I'll talk about in a minute. The other thing is there's a file system browser here. You can just look at the file system on the device. This is the structure I showed you earlier, where there's documents, library, and then the app bundle. And you can just open this up. You can click on things. You can see all the files which are on there. There's a bunch of images apparently also. Just double click on any image. It just downloads it. It shows it to you. You can just look at anything which is on it. And when you look at the file, you can also down here, you see the data protection class for any file on the device. You can just pull that up. Then there's a nice little feature. If you want to see what an app does over time, let's say you're doing a pen test or something like that. You start up the app the first time, and you want to see what changes happen to data along the way. You can use this rsync and git function. What it does, it creates a new Git repository on your computer, and it rsyncs the entire file system from that app over to your desktop and takes a snapshot. And then you can just open it up in Git-K or some GUI for Git or whatever you would like to use, and you see different snapshots. So whenever you click the Git and rsync button, it's going to take another snapshot of the app folder, and you can see all the changes that happened to the file system in that time. So I think that's the main features here. Right. So I kind of like that XKCD. I don't know if you're familiar with it. So the way we break crypto is not by breaking crypto, right? We just get a hammer and hit somebody over the head to give us the passcode for the device. And I mean, basically what I want to say here is that even if you encrypt data on the device, if your app has a flaw, like a different kind of flaw, which is not a crypto flaw, you can still get access to the data. Let's say you have a database which is encrypted, and your web application in the traditional way has access to that database, and you get you can get access to that database using a SQL injection vulnerability or something, or some vulnerability which gives you access to the backend. The application server will just decrypt the data for you when you pull it out. And similarly here, if you find a bug in an app and the app reads the data for you, the app has the permission to read that data, so it's secure. So I came across this really interesting flaw. I don't know, you're probably familiar with the same origin policy, which usually is a web thing, right? So you're not allowed to, if you run on domain 1 here with your own JavaScript, you're allowed to make a request to any other domain, but you will not get the resulting data back, because that would really be bad. If I could just run JavaScript on my own domain and go to your bank's website and pull back all the information from there. So that's something which browsers prevent with the same origin policy. So what I found in an application was an app which caches documents locally. So the idea was somebody is in a company and has important documents they want to read on the plane. They go into the office, say, oh, I want to have all these 10 documents. They're being downloaded to the iPad. They go on the plane. They can read them there. But one of the document types that would allow you was HTML files. So what about if you would include some JavaScript in that HTML? And as it turns out, if you put JavaScript in that HTML file, which looked like this, which just does an XML HTTP request, which is the usual AJAX way of getting asynchronous data. And then you do a get to a file URL, which is a local URL on the device, it would actually return you that PDF into your variable. And then you could pop an alert box, which just had the whole PDF as a content in there. So the moral of the story is basically if you get to an application level flaw, all your protections from the operating system may be completely bypassed because you're actually running as somebody who has the privileges to read that particular file. So just relying on crypto is not a good idea. You have to look at the whole picture. So that also brings us to a few other small information disclosure things, which sometimes are less well known. One thing is that iOS takes a screenshot every time you background an application. So if you have any app open and you press the home button, it takes a snapshot of that. And that's what's being used when you have this, how do you call this thing? Like when you have the app switcher and you can look through all the apps which are running, that's actually snapshots which are on the device, which it shows back to you to be nice and snappy and responsive. And those files are being stored on the file system, and by default, they're completely unencrypted. And the idea is, if you have I don't know, you have a credit card statement or something open and you press the home button, it's going to take a snapshot of that, and somebody, if you get exactly at that point access to the device, you would get that snapshot. So depending on how paranoid you are and how sensitive your data is, that may be something you're concerned about. And maybe you have seen recently, if you I think Facebook does a text secure and some other apps, if you background that app and look in the app switcher, you actually see only a black screen. I don't know if, has anybody seen that? Especially in Android, yeah. So that's basically probably somebody thinking, okay, maybe we should protect against that. And the way you do this is just by, whenever you background the application, you hide all the sensitive data. So in these cases, which many apps do, they just put you can just put a black screen in front of it, you can blur the screen, or you can put your app's logo in front of it, you can do something whichever you would like to do best. And there's a hook for that, which iOS nicely gives you, which is called application did enter background. And you can just implement a piece of code there which just puts a big logo. We put something across the screen which prevents anybody. I mean, the screenshot will only take that part of the screen and store it. The funny thing is that Apple was aware that this may not be a good thing, but their fix is not really geared towards that. So the funny thing is there is something which is called ignore snapshot on next application launch. And that was introduced in iOS 7. And their documentation says this prevents a snapshot from being taken. But that's not true. They still take the snapshot. They just don't show it to you. So the snapshot is still stored on the device, but they don't show it to you anymore. And their rationale is that it's a UI thing. Let's say you have an app which always forces you to log in when you reopen the app. It looks ugly if the old screen is there for 1 second and then it switches to the login screen. So that's why you can use that flag. But it's not a security feature. So I actually looked at this myself on iOS 7. If you background the app, the snapshots are still being stored. This one is also quite interesting. The CacheDB file, which I just hinted in earlier, is an iOS cache which is automatically on, which caches all HTTP requests and responses. And it's a SQLite database which is stored on the device, and it will, like here, for example, I did a request to, I forgot even which app that was. But this one was sending, as the get parameters, it would send my password and my username. And that request is being stored in that SQLite database, and it's just cached on the device. Earlier, it used to be iOS 6 had requests and responses in the CacheDB. iOS 7 switched to only caching requests and not responses anymore, as far as I remember. Or no, the other way around, obviously. Responses, but not requests. And the way to prevent this is to disable the caching. Because by default, it will cache up to a few megabytes, and then it will just have like a circular buffer or something like that. It will just remove the oldest entries and add new ones in there. The way to disable this, as everything in iOS, is really fine-grained access to it. And you can, there's this cached URL response has the way to say will cache response. So you can implement this function which says will cache response, and the easiest way is to just return nil. And that will simply not cache anything. But you could add custom logic there, and you could say, well, everything which is images I would cache, everything which is like web application data I won't cache, things like that. Depends on the app. And then lastly, I guess this is pretty obvious, but it happens all the time. There was a study from IOActive, which they found that 40% of 40 tested applications banking applications, actually, we're disclosing their credentials and API keys in the log files. And that's actually particularly bad because even in iOS 7, any app can read the log files. So you can download from the App Store a log viewer, which you can run on the device, and you can see the log file. Or you can connect it to Xcode, and you see the log file. So that information is really, really public. And you have to just find some way of using of managing debug statements in a smart way. If it's just simple macros there, or if you find some other way of just don't get debug output into a production build. Right, next demo. All right, so let me start with the log, just for the last part. So this is just using an existing tool called iDevice syslog, I believe. It just connects via USB to the device, and it pulls syslog just like Xcode would. But it's just in here, so you can see things which have been logged in the past. They're highlighted by severity, critical errors, or warnings. So if you keep this running, you can just see what your app is logging while you're using it. Then something which I find neat is the screenshot feature. So if you want to see what an app does when you screenshot it, and you just want to have maybe a proof of concept for if you're doing it for a client, you can just use the screenshot wizard. Let me pull this up. So the way this works is to just ask you to click next. It says, OK, launch the app. It does have a button here, and it will automatically launch the app on the iPad. Then I'm clicking next, and then it asks me to background the app by pressing the home button. So I'm pressing the home button on the device, backgrounds the app, and clicking next. And then I see, screenshot was found on the device, and I can click on it, and it pulls it up from the device, and you can see that there was a screenshot taken. So it's just a quick way of verifying this without digging through file directories and seeing if something got stored there or not. So that was that part. And the cache DBs, yeah. So the cache DBs are just like the same as the storage. I don't even have to go through them. There's a folder here where you can just find all the cache DBs. Oh, there's actually one here. And then also double click on that will just pull it up in a SQLite editor, and you can look what's in there. So that's the same thing. Should give you a pretty quick handle on all those things. Okay. All right. So this is the next section is about the part about talking to other applications on the device. And this actually happens more often than you may think. The weird way is that iOS still doesn't really have a proper way of doing inter-process communication. Originally, people started hacking something together by using the pasteboard and copying, pasting things in the pasteboard. And one app would put it in, the other one pull it out. And that's obviously not a good idea. But then iOS, I'm not sure which version it is, but Apple introduced URL schemes, which we also have on desktops and Android everywhere else. So you can call a URL, and when you call that URL, it's associated with an application, and it will launch the application when that URL is called. And after a while, people started using that to call applications back and forth using URL handlers. And Apple actually said, oh, well, this actually seems to be working pretty well, so let's just say this is our official way of doing inter-process communication. And that's where we're at the moment. So before we talk about these ones in detail, if you just want to share data between apps, I talked about the keychain access groups before. That may be a better way of sharing data, but you cannot invoke things for that. So for that, we need other mechanisms. Let us first talk about this the old-fashioned way. Anybody remember what a great new thing it was when Apple finally got copy-paste on the iPhone? It was like this big, great presentation, yeah. So any app can read the pasteboard. That's like the big message. And you can just read it, and it's there. And private pasteboards are not really private. You can just, they're just named pasteboards, so to speak. So you can just give your pasteboard a name which nobody else knows. And then another app which knows how that's called can pull data out of it. But that's not really secure. You can just dump strings on your binary and you get the name for the pasteboard. So it's not really a way of getting it secure. So it's no way of using pasteboard for inter-process communication in any kind of way. You may actually want to prevent copy-paste for sensitive data, that people don't copy-paste credentials or sensitive data out of your application. So there's a way to prevent this by adding for a text view UI element. You can say can't perform action, no, for the copy method, and then nobody can copy data out of that. So let's talk about the more serious option here. So that's URL schemes. They are defined in the info plist file, which is the general information file which contains all the metadata about an application. And you can just choose which URL handler you want. So Apple doesn't care. And the interesting thing is that they don't not even care. They're not even enforcing it. So you can just register the same URL handler as another application has registered already. But in either case, if URL handler is being called, you get a call to your to this open URL method in the application delegate, and you call this, and it passes you the location which has been called, and it also passes you the source application. So you know who called you, and it knows which parameters it calls. And this is actually just a simple URL with get parameters. So that's just on the web, like on the web. The problem is you can receive malicious input because anybody can call any URL handler. There's a trust issue if you assume that nobody knows there's a URL handler and you just use it for interesting things, like I'm going to show you in the next slide. And there's this hijacking issue, which is actually Apple saying themselves down here. They say if more than one third-party app registers a handle to the same URL scheme, there is currently no process for determining which app will give them that scheme. So you have two apps which have the same one, and you're passing sensitive data through there. It may be that another rogue app actually hijacks that call and gets the data which is intended for a different application. So that's something to keep in mind for that. So basically, you don't want to have a man-in-the-middle kind of attack possibility here. So what do people do with this? These are examples I've actually seen. The first one is an app which thought it would be a great idea to let an URL handler reconfigure it. So the login server where it logs into could be reconfigured using calling this URL handler and saying, hey, configure server this, port this. And then the next time you launch the app, it will very nicely send all the credentials your way. It will not check anything else. It will just send you the login information for that server. And again, this can be called from anywhere. You can have a advertisement in an iframe on a website or something like that. It will just launch the URL handler and reconfigure your app without you even noticing. The other thing was kind of nice. It was kind of like a banking application which had a web view, and you could remotely tell it what to present in that web view. So you have an app you trust, and you could tell it what website to display inside of it itself. So this is like perfect for phishing, right? You have your banking app, and you can tell it to load your phishing site inside of the banking application and ask it for credentials. So people do really, really wonky things with these URL schemes, and it's not a great idea. So what you want to do if you know who's calling you, for example, if you're using Facebook single sign-on, that uses these URL schemes, basically you tap login in your app, it shuffles you over to Facebook, they're doing some OAuth magic, and it shuffles you back to your application and sends you the OAuth token, which you just have authorized back. That's a fine way of doing things. But you can verify who's calling you. So you can verify that Facebook is actually the one calling you back, for example, if you care about that. And you might want to perform input validation here in case there's any kind of injections or something like that for the client side. Right. Here's another demo for this. Right. So let's start with the pasteboard monitor. Let me pull this guy up. So it's actually just a very simple thing I wrote. You click Start here, and what it does now, it's going to pull the pasteboard on the device because anybody can read it, right? So my general pasteboard has this great URL here right now. And then you can, if the app, from now it's just me, I'm just going to mark this on the device and select it and copy it. Then it will pick that up and will show you, okay, something else has been copied in the pasteboard right now. And you can also define on the right side here custom pasteboards. If there are secret pasteboards or private pasteboards, you can enter the names and we'll monitor them all at the same time. And you can just see if the pasteboard is being used for anything. The other thing is the URL handler tab here. So first of all, you can list all the URL handlers which an app has. Twitter has a bunch of them. I'm not picking on Twitter here. They're actually doing things pretty well from what I can tell. So if you click on this and then you click on open, what by default will happen, it will just launch the Twitter application on the device. You can also add parameters here if you would know what parameters it takes. I believe there is something to go directly to a user, so to a tweet. Whenever you go on a web UI and it launches your app and directly brings you to a tweet, that would go through this. Now, I wrote a little app to show you what can go wrong. It's called URL overflow. You can guess what that may do. So this is my little app, and if you launch it, all it does, it shows the Toorcon logo. So I wrote a small little fuzzer which uses URL schemes to fuzz. You can fuzz URL schemes with it. So let me copy the base URL here. To type it down here into the fuzz string. I'm just going to add it right after here. But you can make a URL which has multiple entry points, and you can define your own custom strings you want to fuzz. And then you just click fuzz. And it's going to launch the app, wait for a few seconds and kill it, and see if there was a crash detected. So this one, the second one, just didn't even launch at all. And on the right side, you see here for the shorter string, it says false in the end, which means it was fine. And this one, a crash was detected. So I guess if it's called URL overflow and you have a lot of A's, you can guess what happened. And I don't think I have, let me see if I can. Yeah, the problem is this device, it doesn't connect to Xcode right now. Well, if you would look in Xcode, you can see the crash report, and you can also see the stack trace, and you can see what happened, that it was an invalid access because they tried to access the 41s, basically. So that is the fuzzer. And I think that's the part about IPC. So that brings us to the last section, actually, which is network communication. The applications can, so it's not like restricted to HTTP anymore these days, right? We have SIP clients and clients which are using custom protocols to communicate with things. And all of those are potential interesting points to inspect when you look at an application. For HTTP, I already showed you can just use system proxy most of the time. And what happens is that you have challenges similar to what browsers used to have. So you have to protect data in transit, you have to authenticate whom you're talking to, and all those things. And obviously, we just use SSL, TLS. Well, I guess I should cut the SSL by now. It's mostly TLS these days. So we have to focus on how is data protected in transit. Well, interesting thing is that Apple does things pretty reasonably by default. So it has a trust store, as all browsers have and all operating systems have, and it trusts only valid certificates. So the default for all the APIs on iOS are actually pretty reasonable. It only trusts, establishes connection to a server if it trusts it. And it also gives you great flexibility to mess with that. And some things are good, so you can make certificate validation stronger, but you can also just completely turn it off, which is very often done like in development environments and then forgotten to be turned back on when you put it in production. And you can just completely accept any certificate. This is really lengthy down here. I don't think we have to go through this. But basically, you have a way to hook each stage of the authentication process with the other server, and you can override it. And you can do custom processing. You can check which cert it is. You can check data in the certificate. And you can do custom decisions based on what you're receiving back. So don't override this. This is no way. Yeah?
Is that how certificate pinning works then?
Yes. So certificate pinning is implemented in one of, let me see. Yeah, I think there is something that is called received request for authentication challenge or something. And you get the entire certificate provided to you in that function. And you can inspect the certificate, and you can make decisions based on the fingerprint or on the signature, whatever you would like. Actually, I'm going to talk about certificate pinning right here. So obviously, you don't want to bypass it. If you in development have problems with running this on your own development server, ask somebody to set you up a certificate and install it on your device explicitly, then it will trust it. Or get a free cert from Start SSL or something like this. They give free certificates out. You can get those. If you want to make so let me put it this way: if you have a non-jailbroken device, you can install any certificate on there to intercept traffic, like you can do on a desktop computer. But the main problem, which people worry about when they just use the regular certificate validation, is that somebody else may issue a valid certificate for them. So let's say your company may have an intercepting proxy, and they may intercept SSL traffic because they're installing their certificate on all desktops and all mobile devices the organization has, and then they can intercept all the traffic which everybody has, even if it's using SSL. If you're using certificate pinning and you have like a banking application or something which is so sensitive that you don't really want people's employers to see that data either, you can use certificate pinning or nation states, whatever you're concerned about. And you pin the certificate by ideally using an existing framework, because it's not that easy to get it right. So a sister company of ours, iSec Partners, has a SSL conservatory framework for iOS, which helps you get that set up. And there's also an OWASP guide on how to do certificate pinning in iOS. So, but first, before maybe not everybody is maybe not familiar what the pinning does. So basically, the idea is that your iOS device over here has many certificates which it trusts as root certificates, like the blue one and the brown certificate here. But your application knows that the service certificate has been signed by this blue certificate authority. And if you if you have this verification process over here, you start off with like a cert being presented, and that's signed by some other cert, and then in the end you end up seeing that the final certificate has been signed by the brown CA. Your device will say, well, I trust this, so this is fine with me. But your app says, well, I know I have been signed with the blue CA, so I don't trust this. So you get a much stronger level of control. You don't have to rely on your operating system to verify who you trust. You can put that trust in your own application, and you can tell, OK, I exactly know who my server is, and I'm only trusting server certificates which have been signed with this, or which have this exact certificate. So it makes it the connection verification much stronger. IDB has a few functions for this, like a small certificate manager, which makes it easy to install certificates on there. I also tried getting this working for the simulator, which is a bit of a pain because you have to manually modify a Trustor SQLite database, which has all the certificates. So I'm kind of moving away from supporting the simulator in IDB. It's mostly the device right now. But you can now easily add entries. You can delete them. And I'm going to show you how that works in a second. If an app uses certificate pinning and you're doing a pen test, if you use something like the SSL kill switch, also from iSec Partners, that will completely hook all the certificate verification functions on the operating system level and just override them to accept anything. So if you have a jailbroken device, and even if you have pinning, you can still intercept all the traffic when you install this and enable it. It's obviously, this is not a threat for somebody who doesn't have their device jailbroken, but if it's jailbroken, basically all protections go away. That's kind of the bottom line of this. OK, maybe I'll just show you this very briefly. All right, so first things first is pull this up. So under tools over here, there was the screenshot tool before. So if you want to install your burp certificate to intercept things, that's like very easy. You just press the install cert button, and your device just asks you to install the cert, and you just press install. So that's like the easiest part. If you want to install a custom certificate, sorry, it doesn't work, then there's a certificate manager here. Apparently I have 3 burp certificates on this device already. And you can just, this is really what's on the device. You can click on it, you can delete things, and you can also import a DER file from your local machine. You can upload it there, and it will install on the device. So that's very easy. And then just for completeness, this doesn't really have to do with the certificate validation. There's like 2 other features which I didn't talk about in the talk. One of them is a host file editor. You can click here on load, and it pulls in the host file from the device. You can modify it and save it back. And you may wonder why that's useful. Well, the main thing I find this useful for is if you have an application which doesn't trust the system proxy or doesn't follow it, or if it doesn't use HTTP and it uses a custom protocol and connects to a certain server and you want to intercept that traffic, what you can do is you can just repoint that host name to your machine you control and then set up your interception or your proxy on that device. And then you can still intercept traffic very easily. Right. So going towards the end here, so there's a bunch of things I have ideas for, and people which have been using the tool before contacted me for, and what to add. Some things would be that the log view could use some grabbing or something like that. The file system browser would be nice to have a search function or a way to upload files and just modify them on the fly. Copy data into the pasteboard. I think that's mostly useful if you want to I don't know, you have a long credential you get. If you're doing a pen test or something like this, you get a long string from a client, which you need to get on the device. It's really a pain to type it in, so you can just copy it into the pasteboard from IDB. Jason Hedix, who works for HP, I believe, for their security branch, he pointed out that looking for privacy-invasive APIs would be nice. So if you do, it's not really for pen tests, it's more like for people being interested to see what an application does. You can just load an app, you run it against it, and you're going to find all the API calls it does, which are privacy intrusive. So they're reading photos or looking at your address book, or they're doing other kind of things on the device. And also, I would like to have the iOS kill switch integrated, that you can just turn it on and off from IDB, so that you can look for those kind of things. So as for installation and how to get it, so it's open source, MIT license, so I guess it's as free as it can get. It's up on GitHub on this URL. And I just recently was able to actually bundle it as a Ruby gem. So if you have a Ruby install, most of it can be done by just doing gem install IDB. It's going to install all the dependencies for you. The only thing you need to have is Ruby, which is supported, and Qt installed. And there is somewhat detailed instructions on the website. And if you have questions about that, feel free to email me or something like that. A lot of people which are not Ruby people have some trouble getting Ruby to work properly, but that shouldn't be a problem. Yeah, so that's all I have. So hopefully you have some questions. If anybody over there is raising their hand, I don't see anything because there's a big light. Yeah.
So, do you think it would be like a reasonable measure to protect the pasteboard by using a hash of some kind, like hashing the user's email address or something, and so that other apps can't find it, or is that totally useless?
Well, I mean, like hashes usually, if you're just using a regular hash, usually you can. It depends what it is, I guess. I mean, why would you want to copy? I guess my question would be, why would you copy the email address of the user into the pasteboard?
I mean, for the name of the pasteboard, because you mentioned
okay.
other apps being able to guess the name and test it. Not necessarily the email address, but something that's not being specific.
I don't know. I don't see a good reason why the pasteboard is a good way of exchanging data with other apps, at least. I guess it really depends. I wouldn't. So definitely, I wouldn't use a static pasteboard name, because that one would be hard coded in some binary. If you generate it dynamically, then you will have the problem of matching it up. But if you're hashing something on both sides, I guess that kind of solves that problem. But I don't know. I wouldn't feel comfortable. I don't think there is an API which allows you to enumerate pasteboards. So if you have something really long and obscure, maybe somebody wouldn't find it. But I wouldn't use it to exchange anything sensitive, my opinion at least. Yes. Yeah. So the pasteboard is shared across all applications. So if you have a collision there between applications using the same name, then everything is getting messed up anyways. Anything else? Well, I'm here till Sunday, so if you want to chat or have ideas, just find me, and yeah, we can chat. Thanks.
Thanks a lot, Daniel. So we have our lunch break starting right now, and to go to lunch, we have a buffet set up near the pool outside, and so